In this video, we will be covering the first item in our payloads required section of the checklist, but before we jump into testing, I want to cover a couple disclaimers. First, as mentioned throughout the documentation of this course and in our intro video, this course is not meant to be a complete and comprehensive penetration test. We are introducing the concepts, teaching the basics, and introducing third-party resources where you can go learn more information. But if you want to become a self-sufficient penetration tester or learn about hundreds of other edge cases, there are better resources out there. In my opinion, this is the best resource if you want to go learn about penetration testing on your own. Just to kind of show what you'll see in here, if we look at the cross-site scripting section, it'll tell us what cross-site scripting is, the impact of these attacks. It'll talk through a bunch of different situations. It has 20 plus interactive labs. There's a cheat sheet down here, and there is prevention methods as well, and you could go in here and we will actually talk through some of these throughout the course, but it has some in-depth examples of how to prevent cross-site scripting as a whole. The next thing I want to cover is our payload lists themselves. We are using small payload lists. As you can see here, for cross-site scripting, we only have a couple of payloads that we're trying, and then we have a long payload list with a handful of other examples. Again, our goal here is to use high percentage success rate payloads in common situations that most app teams might find themselves in. We are not here to get full exploitation. We just want to see the application's behavior, know whether we have a vulnerability present, and then go remediate that issue now that we know that it exists in our environment. If you want to see a more comprehensive list of payloads, this is probably the most exhaustive list of payloads on the internet. Payload All the Things has tons of different sections and sheets where you can look through this and just see just about every payload you would ever need for any type of testing. Additionally, feel free to add any payloads that you want to the short payload list or the long payload list. This is a starting point, and it is sufficient testing for what we're trying to accomplish with this course. But for one reason or another, if there's a test case that you want to add in there, or specific payloads that you want future developers to test for in your environment, go ahead and throw them in those payload lists, the same way that we've been encouraging you to add on to the code analysis document and other things along the way. With that said, even our short payload list here might set off alerts in your security department or get you blocked by your own web application firewalls. So when doing this testing, please let your security teams know that you are going to start testing your applications. And please do not copy random payloads off the internet and throw them into your environment without knowing what they're doing, because that's how you break things or get yourself in trouble. So for the sake of this course, we will mostly be using our own short payload list. We might jump over here to the long payload list, but the goal is to try and get all of our testing done with as little payloads as possible while covering, again, the most ground possible. I encourage every team, even if you are going through this, to get full manual penetration tests done, or at least have some commercial scanners run over your applications, because we are testing high percentage situations, but there are so many edge cases, it's not possible to fit all of that in one course, so it's just better to have professionals come in and actually test your applications. But this is a great substitute for when you don't get pen tests, or if you only get pen tests once a year, once every other year. This is great to fill in the meantime or before code gets deployed to production. And with all that said, we will go ahead and jump right into the cross-site scripting section now. Well, let's talk about what cross-site scripting is and what the risks are at a high level. Cross-site scripting is a vulnerability caused by an application incorrectly interpreting user input as valid HTML or JavaScript. And what that does is it allows an attacker to input some type of malicious script into the application that will eventually be executed by the victim user's browser. We'll do some basic testing here in a second, but some examples of full exploitation would be stealing a victim user's cookie, having that victim user take some action in the application. An example of that might be if we trick the victim user, who is an admin, into clicking on our malicious link. Then what would happen is they would update the attacker's account to change the role from a standard user to an administrative user. Or the last thing that an attacker might try to do is just steal some type of sensitive data that that victim user has access to in the application. There are multiple ways to deliver the payload to the victim. The examples of that would be sending the victim user a link to our attacker website where we're hosting the payload, have that victim user click a link to the victim application itself, or in some cases the payload might be stored in the application itself for the victim user to stumble across at some later point in time. We could spend a really long time talking about the different risks and delivery method nuances, but that's just kind of a quick overview. We're going to be looking at reflected cross-site scripting labs, and for this first one, we're actually just going to put the malicious input directly into this search bar. But as mentioned in the tools video, we do not want to do testing directly in the UI. We want to have an endpoint in Postman or curl, however we want to do that, so that we're actually bypassing client-side controls. So even though we're going to just drop this first payload here in this search bar here, just know that we should be doing that in Postman. I know from doing this lab that there's nothing happening in the UI, so we can do that just for the sake of the demo. But the other thing I want to point out here really quickly is, as I mentioned, stored cross-site scripting is a different type of cross-site scripting. The testing methodology will be the same. We'll use the same payloads. The only difference is, let's say that we were using Postman to actually post this comment on this blog here. If we were to post a comment with our malicious payload, we would then need to go into the UI itself, refresh the page, and actually see how the UI is handling that cross-site scripting payload. So just know, even though the methodology is pretty much identical, we would need one follow-up request just to see how it's actually being served up to the user when they go to this blog post after it's been submitted. In any case, that's enough of my rambling. Let's go ahead and jump into this first example here. We are going to go one by one through our payload list here. If we wanted to add on to this or learn more about specific exploits, again, we could go into these links up here to get more examples. But in any case, we'll just drop this first payload in here, press search, and see what happens. As we can see here, this is returning with the word test, but it's bold. If we were to just type test into here and click search, it would not be bold. So let's actually see why that's happening. If we inspect the page, we can see here these bold tags are this purplish pink color here, telling us that this is coming back reflected to the client and the browser is interpreting this as valid, in this case HTML tags. So let's go ahead and click edit as HTML, and here we can see that our payload is exactly how we entered it to the application. This will become more apparent as to why we're doing this specific view here in a moment. But in any case, now we can go ahead and try the next payload on the list. If we wanted to, we could stop right here and say, okay, users should not be allowed to input special characters, and this definitely should not be interpreted as proper bold tags. So we could stop right here and jump down to remediation, but let's go ahead and see this payload out to the end by using our second payload in the GitHub page. Alright, so this is what cross-site scripting looks like, at least for the example payloads that we're using throughout the GitHub documents. What we've done here is we've used alert to pop up a box on the screen, and inside that alert we just put the number 1. So here we can see that that was interpreted properly, or technically incorrectly, and it caused this pop-up here. So we'll just press OK on that, and again we'll see how this was interpreted. And here we go, is the payload that we entered, and again if we right click edit as HTML, we can see that nothing was encoded. This was reflected directly back to the user in the exact format that we gave it in the search bar. Now if we wanted to see that more clearly, I'll show how this looks in Burp Suite. I know that we're not testing with Burp Suite, but I do think it is a good way to kind of see exactly how this is working. Here we have our bold tags being entered. As we can see, this is the bold test. And then we can see the response that's coming directly back to the user is quite simply just the bold tags with the word test in there. There's no encoding, there's no filtering happening here. So again, we could stop right now and just jump to remediation, but we're going to show a couple more examples that require some of our, I'll say, more advanced or different styles of payloads. For this lab, we actually have angle brackets being HTML encoded. In this lab, we're going to show how we can actually skip over some of our payloads and use context to determine other payloads that we should be trying. So first, we'll start out with the standard payload we tried in the last lab. We'll just try bold tags here. if we go ahead and search for this, we'll see that we don't get the bold test. Instead, we get our input exactly how we entered it. So once again, we'll inspect the page and we'll click Edit as HTML. And here we can see that those bold tags are actually being encoded. So just for the sake of demonstration purposes, I want to show that if we change that and edit it so that it's actually interpreting the angle brackets instead of them being encoded, that would have executed. But because that didn't execute and it was encoded, we can go ahead and skip over any of our payloads that are using angle brackets. So in this case, what we'll do is we'll jump down to the next set of payloads in the list, which will be this JavaScript, and then we'll just continue our way down. So we'll go ahead and search for this. If you understand how these payloads are working, or if you know some things about JavaScript, you would know that this payload wasn't going to work to begin with. But in any case, we still want to see it just to see how it's being interpreted. We'll edit as HTML, and we can see that this colon is not being encoded. We could go ahead and say, as the dev team, we don't want to allow colons in this search box, so let's go ahead and filter that out. But in this case, I think that that's okay to have those colons for blog titles, so we would leave that alone in this case probably. And now our next search for this onload here, we can see that we have these double quotes, but what's actually happening is it looks like it's being escaped by these single quotes. And if we edit as HTML, it looks like that's what's happening here as well. So I'll actually jump down to the final payload here just to show how we could get here a couple different ways. The lab froze up on me and I had to make sure I could solve it afterwards, but in any case, we made it through most of our payload list, and based on context, we could see that a lot of the payloads weren't working because we had the single quotes that were containing our payloads. So what we could try is we would finally make it down to our last payload here, and we would just simply enter this single quote, alert 1 single quote, and we could go ahead and submit this, and we would get our pop-up box there. But let's say that this payload was being encoded still, and we wanted to get around client-side controls. This was covered in the tools video, but I just feel obligated to show it here as well, just in case people skipped the tools video. We could go to our dev tools, go to our network tab, and then we could type some random information in here. And we could right click on this request, and we could say copy as fetch. We'll go over to the console, and we'll actually try and paste this into the console. And as you can see, here's our input right here. So we could go ahead and send this, and we could look at the response, but what we'll actually do is put our payload in here first. All right, now that we've sent that request, we can go down here, open this up, and we can see the URL itself. This is not my favorite way of testing, but it is quick, and it does work a lot of times. We can just take that URL itself, and we could drop it right here in the browser, and we would see that pop-up box as well. What this does is it gets around if there was client-side controls in place, either removing those single quotes or doing some type of other encoding with them. And that's how we were able to solve this lab, and we could again go around the UI and solve it a different way. I have one final lab that I want to show here, because again, the whole point of this is that we could do testing without having any real understanding of what we're doing. We're just looking at application behavior and the occasional payload that fully executes. But in this case, I want to show this lab where we actually have a CSP bypass. If we do our bold tags, we can see that test is bold. That means, like our first lab, if we do script alert script here, we could search, and we'll actually go look at the code to see what that looks like. Here's our payload right here. If we edit as HTML, we can see this is not encoded. Now, we can just stop right here and say that for some reason it's not executing, but we could probably get cross-site scripting. Let's go fix this from the code perspective. But I do want to point out that if we go to the console itself, we can actually see that the content security policy was able to stop this attack from executing. Again, we could jump down to this third payload here, and it would bypass the CSP. I'm sorry, we could jump down to this payload, and it would actually bypass the CSP and execute. But in any case, my whole point here is that the CSP is blocking us This tells us that, so that's an important piece of information. But purely based on the fact that we're not encoding this payload in any way, we could just go ahead and stop and start remediating for cross-site scripting. Now, speaking of remediation, let's actually cover that. If we go to the checklist itself, we have two documents here. The first one is .NET specific remediation advice for cross-site scripting. And then if we jump over here to OWASP, we have some more high-level explanations of what we should be doing. But to quickly cover this, there are two things that we should be doing, and there's a band-aid we'll talk about here in a moment. The first thing that we should be doing, the most important thing, is output encoding. Anytime a user enters special characters, we should be encoding that on output so that the browser doesn't interpret that as HTML or JavaScript. The next thing that we should be doing here is input validation. What we could do is, first and foremost, if a user enters a character that is not on our allow list, like a angle bracket, we could just go ahead and deny that request entirely and move on. Or we could actually sanitize that user input. In here in OWASP, it actually talks about DOM Purify. You can read all of this, it's great information. But in any case, we could either deny the request entirely or remove those special characters before we actually return the input back to the user. And then the last thing we could do, which is a band-aid, is actually implement a strong content security policy. As we saw in that last lab, the content security policy stopped that cross-site scripting from executing, requiring the attacker to put in a more difficult payload, or in some cases there's no payload that would work if it's a strong CSP, which is why we actually check for the CSP way earlier throughout these labs, because that's just a great way to stop a handful of different attacks. In any case, thank you for watching. I hope this explained how we can check for cross-site scripting without having full context or a full list of edge cases. I'll see you guys in the next video.